Yes. Hello, and welcome to a new awesome movie about PIC 12F 508. And this time I built that debugger. This is its circuit, the simple view of it, and this is the complex view. And also all these wires are going inside this PQ2 programmer, and they are connected directly to the pins of the PIC. Well, to that green board actually, that is helping me with this CMD. That is the PIC, the black square there, and it's helping me. This green board is helping me immensely with this CMD components, especially the integrated circuits. And yes, it is looking a bit more bigger than Deep 8 package, but it is resolving the pads where I solder the pins of the. So it's better than a Deep 8. Even if the surface is a little bit bigger than that, it's better. Trust me on that. It's better like that. This is the only the circuit, but here are the entire wires, and is exactly what you are seeing here. And this movie actually is for this art page that I made. And yes, all right, let's open the code to see it running. First of all, I will move from my D drive. This is in my D drive, and I will move I think this file to here. I want to show you how easily it is to use MPLAB, and is already loaded there. And actually it's not loaded like that when it's opening. Let's simulate that as well. Let's say this file is not loaded already, and if I'm opening the MPLAB, that file is not there, but this is how I'm dragging it. Let's see if you can see it. Moving there, and double click on it, and that's it. And now there are the 1, 2, 3 buttons. Build it, program it, and then McLaren to VDD. And so build all, and it says their build succeed. Program it, and yep, is programmed. And McLaren to VDD, and the LED is open on that. But I will come to that in a second. First of all, I want to show you the code. Actually, you can see here 1 and 0. This is a dude. I'm not sure if he is a dude. I think he's an old guy, but very cool guy. He helped me a lot. I'm old, as he is probably, or he is probably older than me. Who knows? But that doesn't really matter who is older. The thing that matters is that he helped me. Well, I come with the idea of this program, and he was good enough to help me to optimize the code, to make it first of all much more smaller. My code was bigger in lines of code, in the numbers of lines of code, but he optimized it for fewer. It's like 10% probably. He optimized it for me, and yeah, I am really amazed of his code optimization and code skills. And yeah, I did a good job myself as well, but he just blew my mind. Look on this delay. It is entirely his delay here. Well, a couple of things probably from me, but not that much, is entirely his delay, and it's just beautiful and very small. And okay, so I run through all this code for you, and I will go back slowly for you. Hopefully you will learn something from it, or better said, for me to remember everything I did here in the future, of course. And the pick that the black guy there, the black chip there, is already programmed with the code. I have here the oscilloscope. It's called DSO 138. It says there. And this, I don't open it, but I can if I want, but I don't want right now. In this case, is not helpful. And what everything is doing, pretty much when I'm pressing, let me go back to the previous image. When I'm pretty much, this is what is doing. Focus. Yes. So on first button is creating one oscillation. On second button 4 oscillations, 12 oscillations, 128 oscillations, 255, 256 or 5. And then the LED. Well, here is a green LED, but I put yellow LED, and it's exactly the same order as here in the art page. So if I'm clicking, I'm not sure how well this camera will catch this flicker, but it's doing it very fast. Not that fast actually. Actually, this is on 20 milliseconds, but I was doing it at 5 milliseconds. It was dimming very slightly, the LED. And this is what is doing, the same button, the first button, what is doing on my oscilloscope. And I cannot, let's see if I can do that with one finger. So it's doing it exactly. So I put a stop on the oscilloscope very quickly, a hold. It's doing exactly as the code says. Actually, I can show you the code. It will be beneficial for you. So do one oscillation, it says here. Do one oscillation, and my do one oscillation is right in the back here. This is the do one oscillation part code, and then do 4 oscillations is the next button that will do this 4 oscillations, and is that button here, which yep, here and here. When I'm pressing on it, this one is the second. I'm not sure how well my eye is perceiving the flicker, but the camera probably is not that good. But you can see it here. Let's see if I can quickly. No, with one finger. Yes. So it's come on, focus. Right. So you see 1, 2, 3, 4. Here is the base of it, and so 1, 2, 3, 4. Right. And yeah, that's the 4. Let's unhold it. And next part of the code, focus, motherfucker. 12 oscillations. So this is the code for 12 oscillations. We kind of work together. I mean, he definitely helped me a ton. But I did my brain activity as well. I did thought of it. This actually, probably I'm making this movie too early because this code is not optimized yet. All this what is called 1 oscillation, 4 oscillation, 12 oscillation, 128 and 255. All this I made here, but is not yet optimized. I wait to see if that guy can optimize much more of it as it is right now. But as it is right now, is working fine. I'm very, very happy with the function. So the third button here is 12 oscillations, which is this one, the third one. And if I'm pressing, let's see if you can see it. In reality, the LED is doing like that. But the camera, I suppose, is having like a movement. What is called? Not optimizer, movement. I forget right now. But probably that's is a special sensor in the camera that will not really catch the very fast flickering that LED is clearly and visibly. I can see it with my eyes. Is doing it, but very, very fast. And here, when I'm pressing the same button, is creating that trail. Let's see if I can. Yes. So trust me, believe me, there are 12 there, and I actually numbered them to be sure. Okay, so the next one is 128, and for this one, you can see is now is back. It was dimmed, but in reality it was flickering very, 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 very fast, and for a longer time. And here is the train of signals that is creating. That's the 128, and this is 255, which is longer, and I will not film the LED, but I will show you only this because it's a long it's a very long signal. So yes, that's pretty much it. Like I said, all these wires are right now for programming the PIC and also testing in circuit, like you are seeing it right now. These two wires are for from the oscilloscope here, this guy and that guy. But the final product, when I will transform it as a final product, I will unsolder every wire from the pins of the PIC pretty much, and I will link it to this other board, this board or that board, whatever I want, and link it to its external oscillator. And making it as an external oscillator, I will oscillate by clicking each button how many oscillations I want to send to the programmed PIC with a specific program, and I will cycle through its program. This should be an universal debugger for PICs, probably for every microcontroller there is there. Who knows? I don't know. I definitely didn't try anything. It is my idea, everything you see here, my concept. Probably it's not a new concept. Probably somebody will find it elsewhere, somewhere in a device. But I definitely thought of it by myself, and I didn't steal or copied any circuit from. If I was finding a circuit, I was copying it. I am not ashamed of copying it, but I didn't find anything. So I had to actually think very hard how to do it, and I'm not even sure if what I did here is completely useless. If it's proving to be useless, or it will prove to be very helpful. I have no idea what I did here, but as a project in itself, it's a good thing, and I hope it will help me debug other PICs programs in them. Hopefully, I really hope that. The other thing, like a parenthesis here, let me focus. So it's very good to have multiple boards with PICs on them, like this. If I want to program the PIC and test it on this board, I plug it there and I test it. And if I'm uncertain of this PIC that is behaving weird, or the program is behaving weird, I took it out from there and I use this spare board and I plug it in and test the code, see what's happening on this board, which is a bit more complete than that board. This board is having only 4 LEDs. My board here is having 5 LEDs, semi-D LEDs. You can barely see them, but they are there. And also the third board, which is a bit weird, but yes, I think it can be used as a programmer. But I don't want to use it as to program the PIC inside it. I want to use it as a debugger by itself. And but is an option, as a supplementary board. If everything else fails, I can use that as well. Drag some wires like I did here and test it, and yeah, it's another option. It's good to have multiple options, is what I'm saying. All the boards are having all the chips on them already. I never took them out. I just leave them there, and I'm taking it out when I'm programming something new, but usually like 95% I'm programming and super soliciting only one chip that is there all the time, pretty much. And yes, that's it. This is I conclude with this. I have nothing else to say. Next movie will be about how I will use this debugger on a already programmed PIC, like on this board probably, and link everything to this guy to transmit. Actually, is only one pin there, the oscillation pin. That is this wire here. Plus and minus wires. 3 wires are coming out from this board. 1 signal wire and 2 power wires that I will power directly on this board, those two power wires, and the signal will go to the to one of the oscillators pins, OSC1 or OSC2, whatever. I think doesn't matter which one you choose. You can choose one of them. And this will be next time. Hopefully I will get there. But I'm very, very, very pleased with the program, and the functionality is absolutely exactly as I wanted. One single detail. if I'm pressing I hope you can see. If I'm pressing like that, I hope you can hear it very, very quickly. Let's focus. So if I'm pressing very, very quickly, it's doing it exactly as I'm pressing it. No, I didn't catch it. So yeah, it's exactly is responding very, 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 very good to my how fast I press. I had a very big problem with how fast I was pressing, but now it's resolved totally. It's perfect. I'm super happy, and it's all because of this code that is here, and it's doing the magic. It's doing all the magic. And yes, this is it for now. And yeah, thank you very much for watching. I will leave you with my circuit schematic here, and I hope I will hear from you, and leave a like. And I hope I will hear from you in the comments or something, saying a big thank you for my work. Alright, goodbye, and be well, be nice.